and my subject is digital circuits. So first, the main topics are Boolean algebra, logic gates, combinational logic circuits, sequential logic circuits, and microprocessors, A to D, D to A converters, and logic families. Let us start with the Boolean algebra. The first topic is Boolean algebra. So in the Boolean algebra, all the Boolean relations will depend on the following 8 rules. They are 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1. Next, 0 into 0, 0 into 1, 1 into 0, 1 into 1. All the Boolean relations will depend only on these rules. If you know these rules, you can find out any Boolean relationship. And among these 8 rules, this is very easy. Directly we can write as 0. This has also 0. This also has 0. And this is 1. Whereas here, 0 plus 0 is 0. This is 1. This is 1. And only this may be new to you, because 1 plus 1 in the arithmetic addition, what we know is 0 with carry 1. But whereas in the Boolean addition, 1 plus 1 is only 1. In the Boolean addition, 1 plus 1 is only 1. So having known these 8 rules, it is very easy to derive any other Boolean relationship. So for example, let us derive some standard Boolean expressions. The first one, A plus 0 is A only. A plus 0 is only A. Similarly, second one, A plus A is A. Third, A plus 1 is 1 only. Any Boolean relation, even if you don't know, you can easily derive, provided you know these rules. For example, you want to know what is A plus 1. So first you substitute A plus 1, what you want to know. First you substitute A is equal to 0. That implies 0 plus 1 is 0. Now you substitute A is equal to 1. That implies 1 plus 1 is also 1. 0 plus 1 is 1 and 1 plus 1 is also 1. So in both cases, whether the value of A is 0 or A is 1, in both cases we are getting the result as 1. Hence A plus 1 is A. Sorry, A plus 1 is 1. In a similar way, you can derive this also. If you substitute A is equal to 0, we will be getting 0. If you substitute A is equal to 1, we will be getting 1. Same way, A plus A complement will be 1, because if you substitute A is equal to 0, 0 plus 1 is 1. If you substitute A is equal to 1, 1 plus 0 is also 1. So in both cases we are getting 1. And fifth one, A double complement is A itself. Sixth one, A into 0 is 0. It is very easy. A into A is also A. And A into 1 is A only, because if you substitute A is equal to 0, you will get 0. If you substitute A is equal to 1, you will get 1. So that means the result depends on the value of A. So hence the result as A. A into A complement is 0. The last one, the ninth one, A into A complement is 0. Then you can expand A plus BC as A plus B into A plus C. You can expand A plus BC as A plus B into A plus C. Using this relation, you can write the 11th relation as A plus A bar B can be written as A plus A bar B into A plus A bar into A plus B. Since A plus A bar is 1, you will get A plus B only. Eleventh A, same way, A plus A bar B, A bar plus AB can be written as A bar plus A, which is equal to A, which is 1, and A bar plus B. Hence the result is equal to A bar plus B. A bar plus AB can be written as A bar plus A into A bar plus B in a similar line with 10th relation. So where A bar plus A is 1, so only you will get A bar plus B. So these are the Boolean relationships which are all based on the 8 identities what you have derived. Now let us solve some problems. AB plus A into B plus C plus B into B plus C. Let us simplify this. AB plus A into B plus C and B into B plus C. This is AB plus AC plus B into B plus BC. Just I multiplied, the first step is just I multiplied. Then we know that AB plus AB is only AB. So B into B is also B. So now I am combining these two. AB plus AB as AB only plus AC plus B plus BC. What I did is AB plus AB I have written as only AB and B into B as only B. Then afterwards you take these two terms for simplification. AB plus AC plus B into 1 plus C, AB plus AC plus B. So if you take B common here, you will get 1 plus A plus AC. So this is equal to B plus AC. So all steps are self-explanatory, whatever I have written. So wherever I am underlining, that indicates I am taking those two terms for the combination. The second problem, AB bar plus A bar B plus AB. This is very simple problem which you can do just by inspection. So in the last two terms, if you take B common, A plus A bar is 1 plus AB bar. So A plus A bar is 1, then you will get AB bar plus B, which is equal to B plus A. This is very simple problem anyway. Third, A bar BC, AB bar C plus ABC bar plus ABC. Third problem, so in the last two terms, if you take AB common, C plus C bar is 1 and now I am taking the last two terms for combination. The first step is I have taken AB common, so you can write C plus C bar, and we know that C plus C bar is 1. And now I am taking in the last two terms, I am taking A common, A bar BC plus A, B plus B bar C. So B plus B bar C is only B plus C. So you'll get A bar BC plus AB plus AC, because B plus B bar C can be written as B plus C. So you'll get AB plus AC. And first and last, you are taking C common. So if you take C common, it can be written as A plus A bar C plus AB. Then again AC. In the last two terms, if you take C common, you will get A plus A bar B. Please make a correction here. In the first and last terms, if you take C common, you can write as A plus A bar B. So this is AC plus BC plus AB. This is a simplified one. The same third problem I am writing once again. So for this I am adding ABC two times, because ABC is an existing term. The same problem I am doing in a different way. So I am adding the ABC twice, because an existing term can be added as many times as you want. An existing term can be added as many times as you want. So ABC I have added twice. So now how simple it is. So first two terms, next two terms, last two terms. So in the first two terms you will get BC, then you will get AC plus AB. First two terms, if you take BC common, you can write A plus A bar. Second and third and fourth terms, if you take AC common, B plus B bar. And last two terms, if you take AB common, C plus C bar. So we got directly. So what is the logic we used here? There are four terms, out of which ABC is an existing term. ABC is already there. So what I did, I have added ABC twice, because an existing term can be added as many times as you want. Because ABC is there, ABC plus ABC plus ABC plus ABC, however may be the number of times you are adding, you will get only ABC. So by using that property, the ABC is an existing term, that's why I have added ABC two times, then it will be very simpler to solve this question. Now the same third question, let us see how to solve in a different way. Let us call that as a shortcut method, AB bar C, ABC. So now we are going to solve this problem in the shortcut method. Means within one step you can solve this. For example, in the last two terms, what expression you will get in the last two terms? Suppose if you take AB common, C plus C bar is 1. If you take AB common, C plus C bar is 1, so you will get only AB. So in the last two terms I am writing only AB, because in the last two terms if you take AB common, C plus C bar is 1. Now if you assume that I have taken A common here in the last two terms, suppose if you take A common, it can be written as B plus B bar C. If you take A common, it can be written as B plus B bar C. So B plus B bar C means B bar can be eliminated. So simply eliminate B bar here. Now in the first and second terms, if you take C common, it can be written as A plus A bar B. So A bar can be eliminated, simply eliminate A bar. See how easily we got the solution. Only one step, direct method. Next, fourth problem. X plus y into x plus yz plus x bar y bar plus x bar z bar. Simplify this, try this for a minute. First you multiply both. X into x is x, then xyz plus xy plus yz plus x bar y bar plus x bar z bar. Just I multiplied. The first step is just I multiplied. And x into x is x anyway. So 1x I have eliminated. Then in the first three terms, if you take x common, 1 plus yz plus y plus yz plus x bar y bar plus x bar z bar. And remember, 1 plus something is always 1. 1 plus something is always 1. So you will get only 1 here. So then you will get here x plus yz plus x bar y bar plus x bar z bar. Now if you take the first and third terms, here x into 1 plus yz plus y, 1 plus something is always 1. So we have written only x. So x bar y bar plus x bar z bar. Then in the first and third terms, if you take common, means x plus x bar y bar, x bar can be eliminated. So x plus yz plus y bar plus x bar z bar. And first and last terms, again you can eliminate x bar. And here z bar plus zy, z can be eliminated. So x plus y plus y bar plus z bar. And we know that y plus y bar is 1. Then you will get 1 plus x plus z bar, which is equal to 1. Because 1 plus something is always 1. So the result is 1. So now let us see how to solve this problem by using the shortcut method. Within one step, let us see how to solve it. So after multiplication, so here if you take x common here, so like this, 1 plus yz plus y, then you will get only x. So if you take x common, these three terms, the two terms can be eliminated directly. Now I am using the shortcut method. Then in the first and third terms, you can eliminate x bar. And first and last terms, you can eliminate x bar. And second and third terms, y bar plus yz, you can eliminate y. So you see this z plus z bar is 1. Z plus z bar is 1, so 1 plus something is 1, so you will get 1. The result is 1. So this problem also you can solve in a shortcut method. The next problem, fifth problem, a plus a bar b plus a bar b bar c plus a bar b bar c bar d plus a bar b bar c bar d bar e, and so on. Continuously, it continues. We have to simplify this. Actually, this problem also can be solved using the direct method, but I will be explaining only the step-by-step method. So a plus a bar b, you can write a plus b, a bar b bar c, plus a bar b bar c bar d, and so on. And in the first and third terms, it is in the form of a plus a bar b. It is in the form of a plus a bar b, where b is equal to b bar c. Where b is equal to b bar c. So you can eliminate a bar here. So a plus b bar c plus a bar b bar c bar d, and so on. Assuming b bar c as only single b, assume that b bar c as a single entity, that is, let us say b, a plus a bar b. It is in the form of a plus a bar b, where b is equal to b bar c. Hence we can eliminate a bar. So here this what we have written is a plus a bar bc. Bc you take as a b bar c, take as a single entity. So it is in the form of a plus a bar b. So you can eliminate b here. You can eliminate a bar. A plus a bar b bar c means a bar eliminated. So I have eliminated a bar here. Next again, if you take here b plus b bar c, you can eliminate b bar. So simply you will get b plus c. So you will get a plus b plus c plus a bar plus b bar plus c bar plus d, and so on. Again, if you take the first and last terms for the combination a plus a bar b bar c bar d, a plus a bar, you can eliminate a bar first. So first I am taking these first and last terms. Then you will get a plus b plus c plus b bar plus c bar plus d, and so on. Again I am taking the second and last terms. So now we can eliminate b plus b bar means b bar can be eliminated. So a plus b plus c bar d, c plus c bar d, c plus d, and so on. So the answer is a plus b plus c plus d plus e until z. Consensus theorem. Now let us see what is a consensus theorem and how to apply this consensus theorem in the Boolean algebra. So this is the consensus theorem. Xy plus x bar z plus yz is equal to xy plus x bar z. Xy plus x bar z plus yz can be written as xy plus x bar z. So let us see how to apply the consensus. So if you want to apply the consensus theorem, there should be a variable in complemented and uncomplemented form. that means x and x bar. There should be a variable in complemented and uncomplemented form. So let us say here x bar and x. It is there in the complemented form and uncomplemented form. Then you observe the multiplication factor of that variable which is in complemented and uncomplemented form. So the multiplication factor of x is y, the multiplication factor of x bar is z. And there is a product term yz which is coming from the multiplication factor of x and x bar. Then that product term can be directly eliminated by using the consensus theorem, and simply you can write as xy plus x bar z. I will repeat. Consensus theorem says that if there is a product term which is obtained from the multiplication factor of a variable in complemented and uncomplemented form, then that product term can be directly eliminated. Means, if you want to apply the consensus theorem, there should be a variable in complemented and uncomplemented form. So here which variable is like that? X. Then you observe the multiplication factor of that variable in complemented and uncomplemented form. So for example here x is the complemented and uncomplemented form. For x it is y, for x bar it is z. So there is a product term yz which is coming from the multiplication factor of the variable in complemented and uncomplemented form. Then that product term can be directly eliminated and we can write xy plus x bar z. That product term yz can be eliminated. This is called as the consensus theorem. And vice versa is also true. Means if xy plus x bar z is given, you can write xy plus x bar z plus yz. That means if required you can add this redundant term yz. The redundant term yz can be added if required. Sometimes it is required to add the redundant term. So here we can add the redundant term yz. So let us prove this consensus theorem. xy plus x bar z plus yz. I am multiplying yz with x plus x bar. There is nothing wrong by multiplying yz with x plus x bar because x plus x bar is only 1. X plus x bar is 1, so you can multiply yz with x plus x bar. xyz plus x bar yz, and first and third and second and fourth, if you take in the from the first and third terms xy plus 1 plus z and x bar z plus into 1 plus y. So 1 plus z is 1 and 1 plus y is 1. You will get xy plus x bar z. So the consensus theorem is proved here. Now let us solve some problems on consensus theorem. xy plus x bar y bar plus yz is equal to xy plus x bar y bar plus x bar z. You have to prove that xy plus x bar y bar plus yz is equal to xy plus x bar y bar plus x bar z. That is the question. So here if you can observe that, suppose if you are taking the left hand side, the first two terms are same on both sides. xy plus x bar y bar plus yz, xy plus x bar y bar plus x bar z, the first two terms are same. Suppose I am taking the left hand side, xy plus x bar y bar plus yz. Suppose we are taking on the left hand side xy plus x bar y bar plus yz. So suppose if I want to prove that is equal to the right hand side, which term is missing or which term is missing here? X bar z is missing. You can observe that xy plus x bar y bar z is same on right hand side, only this term x bar z is missing. That means if I add the term x bar z on left hand side, then the terms on both the left hand and right hand will be same. If I add the term x bar z on the left hand side, both the will become same. So is it possible to add x bar z by using the consensus theorem? Let us think. Suppose if I apply the consensus to y and y bar, if you apply the consensus to y and y bar, you can add the product term x bar z without any problem, because this is what? xy plus x bar z means you can add yz. How I have added yz here? Y is the multiplication factor of x and z is the multiplication factor of x bar. So we have added the product term yz. Same way, if you apply the consensus theorem to y and y bar, you can add the product term x bar z by applying consensus to y and y bar. Suppose now if I want to prove that is equal to the right hand side, which term is extra? Yz is extra term. Suppose if I eliminate yz, then all the terms on the left hand side and right hand side are equal. xy plus x bar y bar plus yz plus x bar z. So is it possible to eliminate y bar yz? Yes. You apply consensus to x and x bar. Apply the consensus theorem to the x and x bar. So if you apply consensus to x and x bar, you can eliminate the product term yz. So then you will get only xy plus x bar y bar plus x bar z. So now we have proved that left hand side is equal to the right hand side. Next, second problem. xy bar plus yz bar plus wxz bar is equal to xy bar plus yz bar. Now for this problem, you take the left hand side and try to add a redundant term. Take the left hand side and try to add a redundant term. So by applying the consensus theorem to y and y bar, you can add xz bar. By applying consensus to y and y bar, you can add xz bar. Then again, if you take common in these two, xy bar, yz bar plus xz bar. So here again you apply the consensus theorem. So if you apply the consensus theorem here, again apply the consensus to y and y bar, you can eliminate the product term xz bar. If xz bar can be eliminated, then you will get xy bar plus yz bar.